Welcome, Calculus AB. This is 2 for the chain rule, part 2. The essential question is, why is it important to watch your parentheses in trig functions? Let's begin. So more examples here following from last time. Find the derivative of this function here. Now, it's a product rule here, right? So I got to follow the product rule if that's my f and g, and my f prime in this case is going to be 2x. For your g prime, you're going to have to use the chain rule within that. So it's going to be 1 over 2 times the square root of 1 minus x squared, I'm skipping steps there at this point, times the derivative of the inside will be negative 2x. And cleaning that up, that's negative 2x over 1. The 2's cancel here, I'm left with negative x over the square root of 1 minus x squared. Alright, so using that property here, I'm going to say f prime, so 2x times regular g, 2x times the square root of 1 minus x squared, and be plus regular f, so x squared, times g prime, which is going to be times negative x over square root of 1 minus x squared. And cleaning this up just a tad, we're going to get an answer of 2x times the square root of 1 minus x squared minus x cubed over square root of 1 minus x squared. And we can leave it like that. That looks good enough. Looks messy, but there's your answer. Let's simplify this derivative here. I'm going to use the quotient rule. So if this is my f and g, my f prime is going to be 1. G prime, again, using the rules of chain rules right here, it's going to be, this g is the same thing as x squared plus 4 to the 1/3 power. So it's going to be 1 over 3 times x to x squared plus 4 to the negative 1/3. So x squared plus 4 to the negative 1/3. And then times the derivative of the inside, so it'll be 2x. And I can clean that up as 2x over 3 times x squared plus 4 to the positive 1/3. I'm going to leave it as those kind of exponents. So that's g prime right there. Now, let's actually plug those in. Oh boy. So it's going to be 1 f prime times regular g, so I'm going to go x squared plus 4 to the 1/3 power minus x times g prime, so times 2x over 3 x squared plus 4 to the 1/3 power, all over g squared. So the nice thing with squaring it, when you have this exponent, it'll be x squared plus 4 to the 2/3 power. Alright, so simplifying this, I'm going to have to clean things up. It's going to be a lot of messy work here. So it'll be x squared plus 4 to the 1/3 power minus 2x squared over 3 times, you know what, I'm actually going to move the exponent to the top. It's going to help me with my math. So over 3 times x squared plus 4 to the negative 1/3. All over x squared plus 4 to the 2/3. And I want to break this up. So I guess you could leave it like this or leave it on the bottom, but we got a lot of the same things with different exponents. Let's combine these terms on this top. So this side is going to combine to x squared plus 4 to the 1/3 over x squared plus 4 to the 2/3. All right, and over here we're going to combine, this is going to be negative 2x squared times x squared plus 4 to the negative 1/3 over 3 times x squared plus 4 to the 2/3. Okay, 1/3 minus 2/3 is going to be negative 1/3, so that means this is going to be 1 over x squared plus 4 to the positive third, because on the denominator. And now I have negative 1/3. If I moved it to the bottom, this would be 2/3 plus 1/3, which would be 1 whole. So it'd be minus 2x squared over 3 times x squared plus 4. You know what? I'm going to leave it in this format. We're good. That's it on that one. All right, next one. Simplify the derivative of the power. Wow. Okay. So chain rule here. Y prime is going to be 2, and your inside is this quotient, so it's going to be really messy. It'll be 2 times 3x minus 1 over x squared plus 3, and then times the derivative of the inside. So I'm going to leave a spot over here, and I'm going to find the derivative of the inside over here. I'm going to do this work on the side. 3x minus 1 over x squared plus 3. That means your f prime is going to be 3 and g prime is going to be 2x. So you have 3 times 3x minus, oh, not 3x minus 1, 3 times x squared plus 3 minus 3x minus 1 times 2x all over x squared plus 3 squared. Okay, distributing this term, so I'm going to get 3x squared plus 9 minus, and distributing this 2x, minus 6x squared plus 2x over x squared plus 3 squared. And making that a little easier to read, I will make that negative 3x squared plus 2x plus 9 over x squared plus 3 squared. That is what's going in those parentheses. Yeah, so I'm going to rewrite this work. So y prime equals 2 times 3x minus 1 over x squared plus 3 plus this derivative here. Negative 3x squared plus 2x plus 9 all over x squared plus 3 squared. Okay, so let's try to clean this up a little bit and combine what we can. Writing on the bottom, this is going to be x squared plus 3 cubed. On the top here, we're distribute this 2 in. So I'll call it 6x minus 2 times negative 3x squared plus 2x plus 9. And you can leave it just like this. We're done with that one. Moving on. Chain rule and trig functions. So this still works for trig functions. So derivative of sine of u would be cosine of u times u prime. And that's how you do things like sine of 6x. So it's an example from last video. So it becomes cosine of 6x times derivative of the inside. So 6 times 6. So it became 6 cosine of 6x. Anyways, let's do some more of the examples like this. So sine of 2x would be cosine of 2x times 2, which is 2 cosine of 2x. Cosine of x minus 1, derivative of the inside is 1, so it'll be cosine, not cosine, negative sine of x minus 1 times 1, so it's just negative sine x minus 1. This one right here, tangent of 3x, this derivative of tangent of something is going to be tangent, of course we know what this is, let's just review that so you know, secant squared of u. So this is going to be secant squared of 3x times the derivative of 3x is 3. So I can rewrite that as 3 secant squared of 3x. And one thing you have to watch, we've talked in the class about this with the trig parentheses. The reason we put the coefficients in front of that cosine is just, you got to make sure you know what you're talking about. So cosine of 3x squared, if I have no parentheses, I imply cosine the 3x squared is in parentheses. Okay, this is different from saying cosine of 3 times x squared. Cosine of 3 is just some number. So all these formats right here are different. If I did cosine of 3x, all this squared right here, this is actually implying that you're only squaring that 3x. You're not actually squaring the cosine. So it becomes cosine of 9x squared. So you have to watch these different formats. So this first one, the derivative of that would be 6x, negative 6x sine of 3x squared. And derivative of this one would be 2 times cosine of 3 times x squared, times x. It's the cosine of 3 times x. Derivative of this one is going to be negative 18x sine of 9x squared. Derivative of this one would be 2 cosine of x times negative sine of x, which would be negative 2 cosine of x sine of x. And derivative of this last one would be 1 over 2 cosine of x, square root of cosine of x, times negative sine of x. And that would combine to negative sine of x for 2 square root of cosine of x. All right. So chain rule. Sometimes you can go deeper. You can chain a chain. Keep going deeper. So I can rewrite this as sine of 4t to the third power. So derivative f prime of t, you got the sine of 4t, but then you have the 4t inside of the sine. So we're chaining, we're just going deeper. So it's going to be 3 times sine of 4t squared, and then derivative of sine of whatever is going to be times cosine of 4t, and derivative inside the 4t is going to be times 4. So cleaning that up, that's going to be 12 sine squared of 4t times cosine of 4t. All right, so you can go deeper. And we're going to save this for class.